So whoever attended the first session today already knows this, but I'm Raminta. I chair the MQ stream, and I'm here to help bring MQ knowledge to people in the best possible way. So here with me today, we have Claudius and Dragos from Ensono. They will be presenting a bit of Ansible. They very kindly agreed to take questions throughout the session. And also, as I always say, their contact details are in our agenda. So if you have any further questions and we run out of time of questions, just send them directly to them. The chat is available as well for you to submit the questions, so I can read them out later on, or I can just address them and you can ask them yourselves. But yeah, without further ado, guys, the floor is yours. Have fun.
Okay, welcome to everybody who joined the session. Today we'll show what we are working for in case of MQ upgrades and using automation. But let's start from some background. A few words about myself. I'm Claudius Konieczka, and I'm working for Ensono, currently 24 years in IT. 18 out of that is on the mainframe. Starting from mainframe operator through system programmer. Now I'm leading mainframe department in Ensono. I'm mostly interested in mainframes and cybersecurity. I'm located in Gdańsk in Poland, and I'm also a member of GSE, SHARE, and PDAC. Dragos, a few words from you.
Thank you, Claudius. Hello, everybody. My name is Dragos Georgie. I am also based in Poland, in the south of Poland. I've been working with mainframes since I was 19 years old. Of course, started the path as an operator for the first 7 years. Then I've moved on to CICS MQ systems programming, about 2 years of cybersecurity. And recently I've joined Claudius in Ensono. I believe that I have a good set of experience based on the years spent in so many different companies. And I'm passionate about MQ. And some of my hobbies, as you can see, are motorcycles. I like to ride motorcycles, especially fast ones, unfortunately. I like mountains. I like the mountain scenery and wildlife. That's about it.
Okay, few words about Ensono as a company, just to show why we would like to automate things. We have more than 350 customers. Out of them, 150 are using mainframes. Yes, we are very mainframe-centric company. And also it means that we have a lot of tasks related to software lifecycle management. Yes. And for us, supporting so many environments is a challenge. Yes, we have a lot of complex environment to do, and we are looking for the way how to automate things. Yes, and we choose MQ as a first upgrade to be automated because compared to others, it's pretty, let's say, simple. Yes, we can compared to others, we can do it much easier. Yes. Mostly based on copying files, upgrade without using SMPI, and also it's just a first step in our journey. We are checking if it's doable, if how complex it is, and if we succeed, we we are planning to do more. Yes, and after we done it for MQ, our next goal is to upgrade CICS kicks using Ansible. Okay, few high-level words about upgrades, importance and challenges in manual upgrades. For sure, with every maintenance, with every upgrade, we are enhancing security. The settings which are coming to the systems are fixed. We are also getting new features. In every new version, the performance is improved. And also upgrades are required because they need to be compatible with new software which is running on Mainframe, a new operating system, sometimes new hardware. That's why we need to be on top versions. Also important things, we need to be current to get the proper support from vendor. If we face any issues and we have old version, and the first request is to do the upgrade. What are the challenges in manual upgrades? Yes, if we are a company like us with so many customers, so many complex environments, it's the manual process is time consuming. It could be there could be errors. There are no, let's say, framework on doing this. There could be difference between people who are doing the upgrades. Also, downtime when we need to switch off MQ. Sometimes it's pretty long, and our customers' architecture not allow us to do. Sometimes we get just 20 minutes to be switched off. There is also issues when we are facing problem and we need to do the rollback. It's sometimes difficult to get and make it work. Even if we succeed, it takes time. And also we need to engage our, let's say, most experienced people, SMEs, to make this happen. That's why we decided to automate the process. Yes, we decided to use Ansible and Python. Ansible, if you don't know, is open source automation tool. It simplifies IT tasks not only on Mainframe but also on the distributed world. It also means that we can have a specialist outside of the Mainframe area. Yes, we have the skills are more available on the market, and we can also use them on the Mainframe zOS environment. Also, Ansible can use Python scripts to extend functionality, and it allows us to really automate all complex scenarios. And Ansible is agentless. Yes, it means that you don't need to install anything on the remote systems. No licensing, no installation, and also no cost in that case. What are the benefits of MQ upgrade automation? For sure, is consistency. Yes, if we have the automate ready and working, all upgrades will be done the same way across all the systems, and we are reducing the risk of human error to zero. Process is efficient. It's also reduce downtime. Currently, our automate can do the upgrade in minutes. Yes, it's sometimes less than 10 minutes, and we are done with the full upgrade. is easily to scale. It's very important in a company like us that we can move it to another customer, use the same solution, parameterize it a little, but it's pretty easy to be to work on others. From the monitoring perspective, we can monitor every step of automation and very quick find some issues, and on very early phase, if needed, we can fix it, or we can decide to do the rollback quickly and do not affect the change window, do not affect the customers. And from the audit perspective, every step is logged, archived, and even after some longer time, we can come back and see exactly what happened. And if we in future are facing some issues, we can exactly analyze and check if it is connected to this specific upgrade. Yes, we have all the proofs in our hands. Okay, to have Ansible working on our mainframes, we need to have a few things ready. SSH need to be enabled, which is something common on almost all machines. It's done, but we need to install Python or SDK for Python. We need to install zOS, IBM Z Open Automation Utilities. We need to have USS, Unix System Services, enabled, and we need to have zOS in version 2.4 or later. And how it looks, the infrastructure. Yes, we have control node on the Linux machine with Ansible. We have SSH connection. And on the zOS side, we have zOS, USS, and Python installed. And Ansible automation, what is good for? Yes, for sure it's good for issue zOS commands, submit jobs, checking things. It's not possible to do IPLs, shut down zOS, just to restart TCP/IP. All these low-level things are not possible to do and need to stay on the current automation tools like MainView, SysView, because as Ansible is outside of the mainframe, if we switch off LPAR, we cannot connect to it, just as that. Or if we switch off TCP/IP, yes, we are losing connection. That's why if we need to have this low-level automation, we need to think about something which is installed on the mainframes. Okay, how the process of the MQ upgrade looks like. Yeah, normally what we are doing on the manual upgrades, we are reviewing documentation, we are checking compatibility. Next, we of course download the code, we installing libraries. Next, we are checking what migration tasks are needed to be done and prepare the test plan. After that, we need to update the documentation, and in case of any issues, there is also a rollback plan. Okay, now we go to the technical architecture of automated upgrade, and I give the voice to Dragos to describe the whole process, how it looks like from the playbook perspective also.
Thank you, Claudius. Hello, everybody. Again, my name is Dragos George. As Claudius mentioned, initially and at its fundamental core, regardless of whether a queue manager is part of a queue sharing group or of a cluster. The upgrade process is similar across a large number of installations, which basically consists of a few steps which can be easily repeatable. So for the purpose of making the script available to a large audience of MQ installations, we have divided it in 3 phases. Each phase will consist of some steps which are repeatable. It's all of the phases are going to start with a consistency check. They will start with a backup, and they will end with an IVP. Phase 1, which, as we can see, consists of upgrading the early code and setting the stage for phase 2. So what's going to happen is that when the script is going to start, we're going to hard code the high-level qualifier of the current MQ load libraries, such as sys1.mq.scsqauth and so on and so forth. So based on this high-level qualifier, the script is going to create on a 1-to-1 ratio a new set of libraries called staging libraries, which we're going to discuss a bit later, using TSO alloc, and then is going to copy, based on the suffix, the code from the new level qualifier libraries into the staging libraries. Then an MQ utility called CSQUD PSM is being executed, the SPM is being executed to ensure or to verify that all the queue managers on the specific LPAR are at the same level. Now, we understand that it's possible that some installations, some LPARs might run queue managers at different levels on the same LPAR. However, from what we have seen so far, the clients prefer, and we prefer, to keep the queue managers at the same level unless there is a big objection. Then all the queue managers are going to be stopped with the information, the list of the queue managers taken from the step number 2 that are going to be stopped via their command prefix. Now, the stop step is going to consist, it has, in a pristine environment, in a laboratory environment, the stop will almost never be problematic. It will always go down because there are no active threads active in there. But in a real life scenario, we can have the situation where the queue manager simply does not go down because of hanging threads. So the script will attempt to stop the queue manager via its command prefix. If after a certain amount of time it still doesn't go down, it will attempt to stop it via mode force. And if also that doesn't work, it will cancel the queue manager. If the return code after the task is down is not 0, then the queue manager will restart the script will restart the task to ensure that the stop is correct, so that when we take the backup, the page sets, the log copy files, and the BSDS are in a consistent state for recovery purposes, and they're not going to have any in-flight threads. Once all the queue managers are stopped, then the script is going to take a backup of the currently allocated libraries, the LPA libraries that contain the current early code. The new early code is then going to be copied from the distribution libraries that hold the new code into the existing ones. And then, since we decided that fundamentally the early code, it's a rather benign process and with a very low risk of failure, we're going to set proc the modules dynamically into the LPA using the same library which is going to be used during IPL, from which the LPA is going to be built. This is to ensure that during the next IPL, we're not going to have any errors if the library is SMS managed, for example. Then the queue manager's early code for each queue manager, again, taken from the list, displayed at step number 2, is going to be refreshed, and the output is going to be checked in the system log to ensure that the refresh is successful. The script also checks that the level in the queue manager job log, when it is displayed at which early code level it has been modified from the one which was present when we executed the second step. And also the fact that the queue manager starts correctly is a convincing evidence that the early code upgrade has been successful. And of course, we run the CSQ IVP program to ensure that everything is fine. This is phase one, which consists of simply of the early code with the backup. Now, when we mentioned at the beginning the use of staging libraries, we said that we tried to build the solution with a very large number of clients in mind. There are some clients that have one queue manager per LPAR or one MQ ecosystem per LPAR, such as LPAR 1 consists of tests, LPAR 2 of dev, and so on and so forth. But there are some that have all of their environments on the same LPAR. We want to separate the upgrade process. So this is where we make use of the staging libraries. The first step, the creating of the staging libraries, has been done in phase one. Again, we execute the same utility for consistency purpose, so to speak, which can be later used. Then we bring the document managers. Of course, there's the exact same, so it's a usable artifact. The exact same steps are going to be followed. If the document manager does not go down, then the script is going to insist until the document manager is in a consistent state. And we run an SDEF for backup purposes, where we create a list of defined commands of every object inside the queue manager. We also dump the page sets, BSDS, and the log files. Now, this happens, the page set and BSDS names are being taken by the script from the MSTR procedure in the proclib, and the log, the name of the log files, is being built by the script based on a syntax of a log copy file it finds in the MSTR, following the principle that every queue manager has two sets of log copies and each of logs, and each copy has 4 iterations. And from there, it builds the entire structure. The script will back up the procedures. It will just copy them into another library. The script will then insert into the step lib of the MSTR and Chin the stage libraries which were created in phase one. So regardless of, because we started from the assumption that all the queue managers are going to use linked lists in a final state, right? Regardless of whether the library that contains the load module is in the step lib or not, even if it's in the step lib, the script is simply going to move it down the road, and it will work. Then the queue manager subjected to intervention will be started. The correct startup is going to be verified by scanning the job log for queue manager initialization complete in the first phase. And the second, so to speak, confirmation is again that we run the utility program. Now, it's worth mentioning, with your permission for a few seconds, that there is a possibility that for some queue managers, the objects required for the IVP program, they will not be present. Now, there is a possibility for us to add to the script the option to define these objects, which are going to be used by the program. However, we felt it's a bit unnecessary since this is a one-time action. So if we do this manually in advance, it will stay like this for the lifetime of the queue manager. And of course, the phase 3, which is the making the hard coding the upgrade and making the new code available to everything on MVS. Now, of course, there are objections, and very valid, that the queue manager upgrade is not done unless every single application that makes use either from the step lib or from the linked list of the new MQ library code has access to the new code. However, for the purpose of this effort, we have focused solely on the core upgrade of a queue manager. When we say hard code, we may basically mean that we remove the staging libraries from the proclib. The script will do that automatically, of course. And we copy the new modules into the linked listed libraries by deallocating them from LLA by making use of, CSV LLA members in the parm lib. updating LLA, emptying the PDS, compressing the PDS, copying, and then re-adding them under LLA control, refreshing LLA, and starting the queue manager with no libraries in the step lib, verifying again the job log, and running IVP, looking for condition code 0, of course, at the end. These are the 3 phases which we have split the upgrade in.
Yeah, and currently we'll show how it really looks on the system.
Bon, with your permission, Claudio. So, as you mentioned, we are not going to show the script in action. Unfortunately, I cannot verify in real time because for security purposes, I had to submit the script under my authority. But we're going to show the picture from the before and after. So now we have a queue manager defined for the purpose of this of proof testing this script. We can let the video play. Sure. We have the arbitrary level of code. It was chosen simply because it was available. The queue managers are currently running, and as we spoke before, before the start, at the beginning of the implementation, as we can see, there are no backup libraries. The name is also arbitrary. It can be changed into anything. We changed it simply because it has the proper security features in place. The stage libraries are also not created. This is what I was trying to demonstrate, that the staging libraries are created during the execution of phase 1. And now the script, I will invoke the script from IMVS. And unfortunately, I will ask, after the script will start to run, I will ask Claudius to move the... okay, now the script is running. And if we move, for example, just there, perhaps we need to skip forward. It needs to be tailored so that it provides information. However, the core functionality is there, present, and working. Yeah, a bit more. I think we're going to have some output from the what libraries were processed, and yeah, a bit more. But it's okay until we see ISPF. This is a lot of output, which perhaps is not in readable human format at this moment. And boom, we went back to SDSF. We see the queue manager. The queue manager's early code has changed from 9.2 as it was initially to 9.3. The channel initiator is also running, which is again another proof of confidence that that the MSTR has started correctly. As we know, if the MSTR is abandoned in most cases, the chain will not start. Here we are in the system log. I'm going to show you the queue manager refresh command via its command prefix deducted automatically by the script. As we can see, it's an automated operator that did all of the refresh, that did all of the activity. And if I'm not mistaken, at some point, exactly, we are going to see now the staging libraries, as mentioned, created as to set the stage for phase 2. They were created by the script as well. And there is a backup of the already existing early code libraries for recovery purposes. Even though from personal experience, it's rare that we need to do a rollback of the of the early code unless there is a human error. Boom. I think now we can move, with your permission, to the demonstration of how the staged upgrade is going to work. So again, we are showing that the channel initiator as let's say as the introduction, and MSTR are running at 9.2. They have nothing in the step lib, as you can see on the screen. So they are picking up the code from the linked list, which we will show also a little bit later. 9.2, the early code, because it was done one and after another, is at version 9.3. In the step lab, we also have one library that contains the load modules. And soon we are going to let the script run. I think now we're going to show the linked listed libraries, which obviously are there. Forgive me. As you could see that during the until the script starts, that it was quite fast to do the early code upgrade, because we actually had to skip almost half or more than half of the video. I think at this moment the staged upgrade script has started. It will, of course, run the CSQ DSPM utility. Then the queue managers will start to go down. I was trying to display the actual Ansible threads which are on the system. The staged libraries already exist. I think soon I will go and check the. Oh, boom! So the queue manager has already started. The queue manager has been brought down. Forgive me. Yes, that is correct. So during the start of phase 2, the queue manager goes down, and now, as with every step, the backups will start to be taken. Now, we do this regardless, because even if we run all the phases one after another, we still do the backups, because for some potential clients, we might need to wait a few weeks or months before we can harden the upgrade. And therefore, the backups need to be there. As you can see, they are starting to be present. Now, they are named, as you can see, based on what they are backing up. BS stands for bootstrap dataset of the queue manager. LG stands for log copy. MKD stands for makedef, which is when we run the sdef. The page sets, of course, are being dumped as well. There's going to be around 17 backups, as far as I know. Now, if we do run this for a large installation, we do understand that there is a concern, because the backups are going to be hundreds, if not thousands, of cylinders in size. So at this point, there is on the table the discussion to set the libraries with an expiration date of 6 months, for example. The queue manager has started. The backups have been taken. The queue manager has started. The level of the queue manager, as you can see, is at the desired one. The procedure in the proclib has been populated with the staged library by with the correct amount of staged libraries. For example, the channel initiator requires NVR1 as well, and as you could have noticed, the library that contains the load module has been simply put a little bit more down by the script. The last user ID that has changed that library was unknown, because it was an automated operator. At this point, the script has executed successfully. It has not thrown any errors, and CSQ IVP has also executed successfully. And that is something which will need to that is on the to-do list for audit and documentation, so that every step outputs exactly what is required. Boom. Should there be a problem and we will need to roll back the queue manager at this step, if there is anything wrong with, for example, the applicative tests from the client side and they don't like the new level of code, we have a procedure which is going to put the queue manager back at the original level by using the linked list libraries. And one thing I forgot to mention during the upgrade, that the two procedures for MSTR and channel initiators are also backed up into a separate library for recovery purposes. Okay, boom. So we can start the video. So now we are going to demonstrate the rollback from version 9.3 from a queue manager that is using the staged libraries to version 9.2 as it was in its initial state, excuse me, using the linked listed libraries. Boom. So the channel initiator and the MSTR are the same version, obviously, of course. Now, in the job log of the MSTR, there is a line, that says that to which level is the backwards migration compatible to. So this is something that the script uses when we are going to do the rollback with the backmig to a specific version. So it keeps in mind now the queue manager. What it's doing is that, so it's starting the queue manager with the parameter backmig with the exact same value that it found here. And the script checks for this thread, for this line, and deducts that the backmig has been forgive me, successful. The backups have been taken, of course, before the execution of the script, and the queue manager has now been regressed to version 9.2. The early processing has stayed the same. We haven't touched that. And the procedures are the same as they were from before the start of the staged upgrade when we did the backup of them. This is simply a copy and replace back into the original proc lib. They are using the linked list. And what is worth mentioning in a few seconds is that if there are problems and we cannot roll back because of a corrupted page set or because the bootstrap datasets have failures or is anything wrong with the log copy files, the script also has the capability of doing what is colloquially called a dirty rollout. So basically what's going to happen is we are going to unpack the bootstrap datasets, log copy files, and page sets from the initially taken dump with the replace option, therefore putting the queue manager in its original state, and simply copying the procedures from the backup to the original ones. We are now, of course, the ITP has also been executed, and now after every queue manager has been upgraded successfully via the staging method, and everything has been confirmed fine from the client and applicative perspective as well, we're going to continue to do the hardened upgrade, which stands for, well, basically updating the linked list libraries. Now, as we mentioned at the beginning, this is the upgrade of a queue manager is mostly a set of file operations and zOS commands. We are now showing that it's using the stage, right? Once the staged upgrade is completed after a period of time has passed. Here we're going to move to hard code the change. Here we are showing the MQ libraries in the linked list, and while the script and the presentation is happening, I would like to also mention that it has a capability. The script also has a capability to roll back during the hardened phase, but however, we feel that once the upgrade has been proven successful using the staging libraries, we find that it's unrealistic to think that if we change the place from where the load modules are being picked up, so if we change from step lib to linked list, is going to be problematic. So at this stage, we already don't expect to execute any rollback, so to speak. Boom. So the number of course, as with the beginning of every phase, the backups are being taken, make defs are being taken, the queue manager is down. Excuse me. And as you can see, it's 2 minutes, and it looks like the script is the backup step is finished. These are the original MQ libraries. The procedures which have been backed up with the Julian date stamp. At this point, I think initially, well, we are showing that the log copy files are being backed up, the bootstrap are being, the makedef has been done. And as with the previous examples, we're going to have a set of 17 libraries because we are upgrading and hard coding the same key manager. Okay, boom, 17 libraries. At this point, we're going to look in the system log for the LLA refresh and LLA update steps, which have been executed to remove the libraries from under LLA management so that they can be updated to avoid contentions. The command has been passed. The script also passes a DLLA for let's say redundancy purposes. If we look somewhere at the bottom of the screen, exactly, we can see that this is the add step, and the script has re-added the already existing libraries which we have shown at the beginning of the presentation in the linked list under LLA management, and that is the automated operator which has done the intervention. The queue manager has started. The channel initiator, we could see that is also starting. The code is at 9.3. The stage libraries have been removed from both the channel initiator and the master address space. At this point, the IVP has executed successfully. And at this point, we can consider the upgrade successful. Again, it has been set in these three phases simply to accommodate a large variety of customers with different NQ architectures. Thank you for your attention.
Yeah, few words how currently we are using this tool. We are using it successfully on our R&D environment and on our training environments. We are successfully upgrading and doing the rollbacks if needed. And as a next steps, we are making our customers Ansible ready, and it means that they need to have all these prerequisites. Also, on top of that, they need to be connection between Ansible Tower and we need to also have special Ansible user created. We need to get all the security approvals, which is sometimes hard to get. We are making this solution to going on production, and we're planning to use it this year. Okay, any questions? We're almost on time.
Very much on time. Thank you very much, guys, for a presentation, first of all. Really good demo. And yeah, the floor is open for any questions. Cautious that we do have only 1 minute. We might just need to address the questions in the personally to you guys in the email, but let's see if any questions at this point. Anyone? Doesn't seem so, but thank you very much, guys. The demo was great. Good to see that Ansible is being used more to our advantage and helping us in terms of how we address things. And as you say, it just minimizes the human error possibility, which is a huge thing for us, especially while driving a busy environment and all that. So this is great. And we are out of time now. So once again, thank you very much for your presentation. Good to have the demo there. We do have a request for everyone to record some feedback if any required. And as I say, just address any questions, further questions to Claudius Dragos directly. But yeah, apart from that, let's wrap up. Thank you very much again. This is recorded, so it will be published again. But thank you very much, and yeah, have a great day. Thank you all.
Thank you. Thank you.
Thank you very
See you
much.
all.
Bye.
Thank you.
Yes.
Bye.
Bye.
Bye.